What's up, Joe Gamers? Today we'll be doing YN math. YN on this another Jocademy BC Joe. YN math, guys. YN only. So we'll be going over what is called Euler method. The Euler method is not sigma at all. Hard to explain, but it's an approximation of a function given some stuff. So I'll first go on with what f of x of. What does it mean? This means it's basically notation for a differential equation, like x minus y, where x is the y, x, and the y is the y. So if I had dy dx equals x squared minus y, my thingy would be, and I put like numbers 3 and 2, it would equal 3 squared minus 2. Yes. Okay. So that's what that function is. Okay. Look at the notes here. Look underneath them. So, look I wrote here. If a question asks if n amount of steps, you get the change in x over m. Okay, and then this says with a step of m, change in x equals m, yn plus 1, yn again. They're always y's. And then here's a table. It's a general table to keep track of what you're doing, because you're gonna need it. And so the x is always increasing by the m. It's always increasing by m. yi is increasing by the change in x. This should be a change in x here. Change in x plus the change in x times the function. Okay, so this is equal to change in x times the derivative plus the original y from the previous. So this one would be this value plus this value times change in x. Okay. Okay. And then 0, 1, 2, 3, because there's stuff in the steps. 0 step, 1 step, 2 step, 3 step. You should write this as n. Okay. Okay. That is general approximation. Let's say e to the x. Okay. And let's say we have an equation dy dx equals and then the steps equal 1. Start from 0. The approximation will look something like this. And if I increase steps or if I increase the amount of steps like this, 0.5, you get a closer and closer approximation. I get a very close approximation of the value. So this is a method to approximate things given only its differential equation. Used when only given this approximation used only when given a differential equation and an f1 or a y0 or y1 equals some value of y, and you're given a derivative something, I don't know. So what you must have to do Euler method is a dy dx, that is f of xy. You must have a function. Okay, either or will be fine. You just need y and x values, and that's it. Okay, so this problem, no problem, no. So we need to find approximation of f of 2.44 given equal size approximation with 2 steps. With a step or with 2 steps of equal size. It sounds more like this definition. Usually this definition is used when you're only given y of a function, and this definition is used when f of o is given, or f of 1 or whatever. In this case, f of o equals 2, so we're going to use that definition. Equal 2. That means that steps equal change in x over m equals 2. That's the steps of equal size. We need just like the increment, and change in x is from 0 to 2.4. X is usually always linear, so it's always going to increase linearly. So change in x equals 1.2. Okay, and dy dx equals x minus 2y plus 2. Okay, now we make our x and y table. Okay, so our first value n, first value 0 equals 2, and then we plug in f of x y, we get f of 0, 2, which is just this times, So what we get is 0 minus 4 plus 2 equals negative 2 equals negative 2. Now that's done. We write negative 2 here, but this, we write change in y. Change in y. Oh, 808. Alright guys, I did it wrong, so I'm gonna do this again. dy plus 1 equals yn plus change in yn times change in x. And then this is equal to change in yn. So negative 2 times 1.2 plus 2 from this is the yn, these are yns. And you get negative 0.4 equals yn plus 1. So we're gonna put negative 2 here. The next one is 0.4 negative, next one is 1.2. Yeah, add 1.2 from here. And then low taper fade. And you see negative 2, you see this right here, and negative 2 times 1.2. So the next value is going to be negative 0.4 times whatever value this is. And we're like, see, or actually it's really change in y n plus 1, change in x, or no change in x. But this one is going to be change in y n plus 1, change in x for the next value. And then this, and it'll be this value, it'll be this entire value, times change in y n plus 2, change in x. That's the shortcut way. That's how you can do it, shortcutly. Okay. So given this, now all we have to do is plug into the equation again. This time, instead of this, we have f of 1.2, negative 0.4. This equal to 4. And then the next value here is going to be 2.4 because we're always adding linearly here. And that would also mean that 4 times 1.2 plus this is the next value here. So 4 times 1.2 is 4.8, minus 0.4 is 4.4. And we don't even know what this is. So that's the answer, 4.4. And we put it in. There you go. Those who know. Let's do one more. Let's do this. Alright guys, this is a number I want you to know. So f of xn equals f of xn minus 1 plus change in x times f of xn minus 1 f n minus 1 plus n minus 2 and so on and so forth. Yeah, that's basically looks like Taylor polynomial series. Alright. That probably is wrong though. I'm not telling for certain if that's right. Actually, that's wrong. It should be something like f of xn minus 1 plus change in x. yn. And so on. Just like that. Looks like a Taylor polynomial series, but not really. So that's what that looks like. You just do it up until xn minus 1. Then you get x of n, and that'll be like so sigma. Or something like that. Don't take me too seriously. Alright, next question is dy dx equal to 2x plus dy plus 3, where y of 3 equals k, y4 equals 6, x equals 3, and step equals 1. So then it asks, what is k? Curve. So now, you just make a table. X, y, dy, dx, where x equals starts at 3, we get 3 and 4 for the steps. And then we have k, 6, and if we plug it in for f of 3k, this would equal 6 minus 2k plus 3, which would equal negative 2k plus 9. So 2k plus 9. I'm on vacation. Fishing go there. And then, before we write this, we gotta write the next term. So it is equal to negative 6, but the final next term is change in x times this plus this, and change in x is 1, we get rid of that. And plus this, it'd be negative k plus 9. And now we write negative k plus 9 equals negative 6. And we can write, and we do it equals 15. K equals 15. Put it in. Whoa.